morning. Welcome to Mathematicon, a place where mathematics is made easy. On this channel, we shall be expanding on the concepts in the areas in numerical analysis, calculus, statistics, and in the nearest future, we shall be uploading videos on robotics, application of mathematics to robotics. So I encourage you to subscribe, to like, and to comment within our channel. Thank you. To be solving an example of joint probability function. So we have the example, let f of x and y be given as 2 over 5 into bracket 2x plus 3y, given that 0 is less than x, less than or equals to 1, 0 is less than or equals to y is less than or equals to 1, and that the function is 0 s real. So the function only has that value within the region of x between 0 and 1 and y between 0 and 1. So the first question is to verify that it's a probability density function. And the second question is to calculate the probability that 0 is less than x, less than 1 over 2, and 1 over 4 is less than y, less than 1 over 2. But before we continue, I would like to ask this question. Based on what you've been taught, is this a discrete probability function or a continuous probability function?
Continuous probability function.
Good. It's a continuous probability function. So, since it's a continuous probability function, to verify that it's a probability density function, we are going to be making use of the condition minus infinity to infinity, minus infinity to infinity, f of x, y, the x, the y, is equals to 1. If this condition can be satisfied, then we conclude that the function we have on board there is a probability density function. So we can substitute into these integrals. So we have from 0 to 1, from 0 to 1. This is based on the values of intervals given here. And this is the density function itself. So we substitute the density function into the integral sign. So we have 2 over 5 into 2x bracket into bracket 2x plus 3y. The x and the y. Now, for us to evaluate this integral, we evaluate the inner integral first with respect to x. You will all agree with me that 2 over 5 is a constant, so we take it out of the integral sign. So we are left with 2 over 5, integral from 0 to 1, integral from 0 to 1, 2x plus 3y, bracket the x and the y. Now, for us to integrate with respect to x, we are going to have 2 over 5 into integral 0 to 1, 2x squared over 2 plus 3yx from 0 to 1 dy. So you will agree with me that 2 cancels 2 and we are left with 2 over 5 integral from 0 to 1 x squared plus 3yx from 0 to 1 dy. So we can substitute the limit of integrals into the function. We'll have 2 over 5 from 0 to 1, x, that's x squared will be 1, plus 3y. Subtract from 0 squared plus 3y0 dy. So, you will agree with me that this part of the equation goes to 0, and we are left with 2 over 5, integral from 0 to 1, 1 plus 3y, the y. So we are left with only y variables now. We can then take the integration with respect to y. So taking the integration with respect to y, we have 2 over 5 into 2 over 5 into bracket y plus 3y squared over 2 from 0 to 1. So, from here, if we substitute 1 into the limit of integration into the problem, we have have 2 over 5 bracket 1 plus 3 1 squared over 2. If you substitute 0, the limit of integration into the function will have 0 plus 3 0 squared over 2 all bracket. Now, this side of the equation goes to 0 like in the previous case, and we are left with 2 over 5 into bracket 1 plus 3 over 2. So, this can be further simplified to 2 over 5 by taking the LCM here, 5 over 2. And 5 cancels 5, 2 cancels 2. So the final answer is 1. So since the condition is satisfied to be 1, we can then conclude that the function fx and y is a probability density function. So, having established that our problem is a probability density function, we go ahead to calculate the probability within these given intervals. So, here we have integral from 0 to half, and here integral from 0 to half. We have integral from 1 over 4 to half, and from here we have integral from 0 to half. Our probability density function 2, 5 into bracket 2x plus 3y, the x dy. So, like we did in the previous case, we take our integration with respect to x. So, doing that, we are left with integral from 1 over 4 to 1 over 2. 2 over 5 is a constant, it goes out of the integral sign. We have 2x squared over 2 plus 3xy, all 0 to 1 over 2 y. So we can further, you will agree with me that 2 cancels 2, like in the previous case. So we have 2 over 5 into integral 1 over 4 to 1 over 2, x squared plus 3xy from 0 to half the y. So if we substitute half, the limit of integration will be left with 2 over 5 into integral 1 over 4 to 1 over 2, 1 over 2 squared plus 3, 1 over 2 y. No. So substitute the second limit of integral, we have 0 squared plus 3, 0 and y. dy. So you will agree with me that this part of the equation goes to 0, and we are left with 2 over 5 into integral 1 to 4, 1 over 2, 1 over 4 plus 3 over 2y dy. So now we can take from here, we are going to integrate with respect to y. Now if we are to integrate with respect to y, we have 2 over 5 into integral 2 over 5 in bracket 1 over 4y plus 3 over 2 y squared over 2 from 1 over 4 to 1 over 2. So here this can be written as 2 over 5 into bracket 1 over 4y plus 3y squared over 4 from 1 over 4 to 1 over 2. So we can consider now the limit of integration. If you consider now the limit of integration, we have 2 over